Good evening. I am Steve May with the Federal Aviation Administration. Tonight we will provide an update on the Southern California airspace modernization, more specifically, the Southern California Metroplex. I am joined by Rob Henry, Southern California Metroplex Project Manager, and Jose Gonzalez, Southern California Metroplex NATCA Co-Lead. The airports we will be focusing on tonight will include Los Angeles and Santa Monica airports. The procedures that will be implemented on the March 2nd and April 27th chart publication dates will be our focus for tonight's presentation. Fundamental to meeting the overall next-gen air traffic management, there has been and still is the need to evolve air traffic to a time-based system. An aircraft must be capable of receiving dynamic and complex instructions from ground systems that identify where they need to be and at what time. This requires the FAA to implement digital communications, leverage advanced navigation performance and flight management systems, and design and implement new airspace and procedures. Once NextGen is fully implemented, we will be able to identify the location of each aircraft at any point in time along the way to its destination. This will have a tremendous impact on our ability to manage air traffic more safely and efficiently. Looking at the Southern California Metroplex study area, the study area covers a large portion of Southern California from Santa Barbara to Palm Springs and down to San Diego. It includes 6 major airports, including Bob Hope Airport, Los Angeles International Airport, Long Beach Airport, Ontario International Airport, San Diego International Airport, and John Wayne Orange County Airport. There are also 15 satellite airports within the study area. The goals of the Southern California Metroplex include improving flexibility and predictability of air traffic routes through increased use of performance-based navigation. The improvements will be achieved by utilizing satellite technology and publishing and implementing advanced procedures. Tonight we will look at several procedures, including area navigation, abbreviated as RNAV, standard terminal arrivals, abbreviated as STARS, standard instrument departures, abbreviated as SIDS, required navigation performance approach procedures, abbreviated as RNP, and optimized profile descent, abbreviated as OPD. Area navigation is a method of navigation that mitigates the limitations of an aircraft navigating from one ground-based navigational aid to a satellite system providing point-to-point operational capabilities. Standard terminal arrival route is a specific, repeatable path with lateral and often vertical descent guidance for arrivals into an airport. Standard instrument departure is a specific repeatable path with lateral and often vertical climb guidance for departures from an airport. Required navigation performance, or RNP approach, is approach providing a higher level of precision than an approach using ground-based navigation. An optimized profile descent is a procedure that keeps arrival aircraft at cruise altitude as long as possible before beginning an uninterrupted descent. Once begun, the procedure departs from the usual pattern of stair-step descent all the way down to landing. We took a phased approach to executing the Southern California Metroplex project. We started out with the study team phase, which completed in December 2011. This phase included potential opportunities and operational issues were identified to determine if a benefit could be developed through the application of performance-based navigation procedures and airspace changes. These designs were highly conceptual. The next phase was the design team phase and was completed in March 2014. This phase was used to refine the study team recommendations and conceptual designs into final implementable performance-based navigation procedures and airspace designs. The next phase was the evaluation phase and was completed in August of 2016. Within this phase, the proposed procedures were evaluated to determine if they met operational, environmental, and safety requirements. And the final phase is the implementation phase, which began on August 31st of 2016 and is currently ongoing. After issuance of a finding of no significant impact, record of decision, activities in this phase are to complete and execute the implementation of procedures developed during the previous phases.
Good evening. I'm Rob Henry. I'm the SoCal Metroplex manager. Let's begin our procedure discussion with departure and landing direction, or runway in use. Wind direction and velocity are key factors used to determine departure and landing direction. Wind speed below 5 knots is negligible. Runways are typically identified by their runway magnetic direction. For example, the west flow runway at San Diego International Airport, or SAN, is 275 degrees magnetic. The last digit is dropped and it becomes San Diego Airport runway 27. The rationale for operating into a headwind is simple. More wind flowing over the wings provides more lift at lower ground speeds. A tailwind makes an aircraft faster across the ground, requiring more runway length. Southern California airports typically experience westerly winds, which favor west operations. Two terms you're going to hear a lot when we talk about satellite-based routes are optimized profile descents and optimized climb profile. Here's how they work. First, the optimized profile descent, or OPD. Please notice the dotted blue line. This represents current operations. A traditional ascent is like walking down a flight of stairs. Based on air traffic control instructions, the pilot descends, then applies speed brakes, then levels off, and then powers the engines up, then descends and applies the speed brakes again. This cycle repeats itself until the plane is on its final approach to an airport. Please note the solid blue line. This represents the optimized profile descent. By contrast, the optimized profile descent has built-in speed and altitude restrictions at various points on the route. These restrictions are designed to provide automatic separation from aircraft on other routes by either vertical altitude separation or lateral distance separation. This information is programmed into the airplane's flight computers and allows the aircraft to glide down to an airport at near idle power. And controllers no longer have to issue instructions after clearing the plane to begin its descent. OPDs are safer in that there is less pilot-controller interaction. Airplanes flying OPDs versus a traditional descent generate less noise and emit less pollution because their engines are at near idle and speed brake use is minimized. Please note the yellow area on the chart. The yellow area depicts a dispersed vectoring area. Current arrival procedures utilize ground-based navigation and radar vectors. Controller vectoring creates a high workload for air traffic controllers and flight crews. Vectoring creates inconsistent flight paths, creating a wide dispersion for arriving traffic. Vectoring also provides for inconsistent vertical profiles as altitudes are assigned by air traffic control. Additionally, arrival procedures are not connected to approaches. RNAV RNP, in this example, two arrival routes or two stars are connected to the RNP. You'll notice arrival route 1 and arrival route 2 are examples of standard terminal arrivals or stars. The star approach connectivity provides repeatable and predictable flight paths. It simplifies operations for the flight crew and air traffic control. It allows use of the flight deck automation and provides a stabilized and efficient approach operation. Next is the optimized climb profile. A traditional climb profile is like walking up a flight of stairs. Based on air traffic control instruction, the pilot climbs and then levels off and powers the engines up and then climbs again. The cycle repeats itself until the plane is at final cruise altitude. By contrast, the optimized climb profile has built-in speed and altitude requirements at various points along the route. These restrictions are designed to provide automatic separation from aircraft on other routes. This information is again programmed into the airplane's flight computers and allows them to climb at optimal power, and the controllers do not have to issue instructions after clearing the plane to climb. The optimized climb profile is much more efficient than traditional climbs and is a key benefit that we are seeing today from our use of satellite-based routes. Optimized climbs are safer due to less pilot-controller interaction. Airplanes flying optimized climb profiles versus a traditional climb generate less noise and emit less emanate less pollution. The benefits that we're seeing is reduced air traffic control task complexity, reduced communication between the flight decks and air traffic controllers, the reduction of phraseology, reduced frequency congestion, reduced pilot workload, repeatable, predictable flight paths, accurate fuel planning, and laterally or vertically segregated flows.
Let's take a look at the National Environmental Policy Act. The Southern California environmental assessment process began with study team participation in November of 2011. The draft environmental assessment was released on June 10, 2015, and the public comment period was open for 120 days. The finding of no significant impact record of decision was signed on August 31, 2016. The final environmental assessment is available on the Southern California Metroplex website. We will provide the website information to you towards the end of the briefing. The finding of no significant impact record of decision enables the agency to move forward with replacing dozens of existing conventional air traffic control procedures with new satellite-based procedures. The FAA began phasing in the use of procedures starting in November 2016 and continuing through April 2017. When the Southern California Metroplex procedures are implemented, some people might see aircraft where they did not previously fly. This is because some air route changes will occur and because satellite-based procedures create more concentrated flight paths than conventional procedures. Some people will experience noise decreases or increases, and some will experience no changes at all. Some flight track dispersion will continue to occur after the new procedures are implemented because the Metroplex project includes a number of existing procedures. Also, air traffic controllers will need to occasionally vector aircraft for safety or efficiency reasons or to reroute them around weather systems. The following noise maps are created to enhance the understanding of all potential noise changes in the study area. Please note that many of these changes occur at noise levels at or below the noise level experienced in everyday living situations in the area. The noise maps represent noise changes of DNL plus or minus 1 decibel. For many people, This small change is difficult to distinguish. The FAA DNL metric is a value representing the aircraft's sound level over a 24-hour period and includes all of the sound energy generated within that period. The DNL metric includes a 10 decibel weighting for noise events occurring between 10 p.m. and 7 a.m., which we considered as nighttime noise events. The FAA did not use these maps for decision purposes. Noise maps are provided for disclosure purposes only. This next slide looks at increase and decrease in DNL at or above DNL 45 A-weighted decibels, or dBA. In the map, you will see a blue shaded area. This represents the DNL decrease. You will also see a green shaded area, which represents the DNL increase. The bold line around Southern California area is the general study area boundary, and the smaller lightly shaded polygons are the community or city boundaries. The 45 and above decibel noise level map is provided based on FAA's established criteria for changes in noise levels. This map looks at increase and decrease in DNL at or below DNL 45 dBA. Once again, the blue denotes the DNL decrease and the green denotes the DNL increase. And again, you will see the general study area boundary, the communities and cities within the general study area. Although there is no established FAA criteria for changes below 45 decibels, this map displays those changes to enhance the understanding of all potential noise impacts in the study area and is provided for informational purposes only.
Next, we'll discuss community engagement. Southern California community engagement began with early notification of the environmental assessment. This took place on January 21st, 2014. The FAA conducted 11 public workshops from June 16th through July 1st of 2015. These workshops were conducted in Santa Ana, Santa Monica, Los Angeles, San Diego, Palm Springs, Torrance, Long Beach, Ontario, Ventura, Santa Barbara, and Burbank. The FAA extended the public comment period for a total of 120 days, closing October 8, 2015. Approximately 4,000 individual comments were received. Approximately 2,700 were unique comments and/or form letters received. Approximately 380 comments were received after the public comment period closed. However, those comments were addressed in the environmental assessment. Approximately 570 comments were received from 3 online community groups, and responses to comments are included in the environmental assessment. Next is community engagement. Based on community comments, the FAA reviewed all procedures. Analysis was conducted and consisted of reviewing the following. First was safety. Will the recommended change have an adverse impact on safe operations? The team considered aviation safety information and sharing data with potential impact to airspace, procedures, and enhancement of safety. We looked at traffic collision avoidance system hotspots, terrain avoidance warning system alerts, high energy descent and approach events. Next, we evaluated efficiency. Will the change create substantial inefficiencies? Next, we evaluated complexity. Will the change increase workload beyond a reasonable level for controllers or flight crews? Next, we'll discuss the March 2nd and April 27, 2017 procedure implementation. This chart displays the procedures that will be implemented for Los Angeles and Santa Monica Airport on March 2nd, 2017. This chart depicts the procedures for Los Angeles and Santa Monica procedures implementation for April 27, 2017 and 17. First, we'll discuss Los Angeles Airport. The first procedure is the Los Angeles Angel 1 RNAV star and the Los Angeles Hollywood RNAV star. Quickly to explain the chart to you, you'll notice in the upper left corner is an insert of the procedure with 1 day of actual traffic indicated in the light blue lines. The orange lines represent the standard terminal arrival, or star. The light blue color closer to the airport represents the arrival procedure. The Angel and Hollywood replace the current River and Seaview stars. The current River and Seaview stars create a bottleneck for arrivals and are responsible for the heaviest volume into the Metroplex area. The star connects to the RNP approach for runway 24 left and right and runway 25 left and right. The Angel and Hollywood stars are OPD procedures. Additionally, there's an offset approach option to the Los Angeles South Complex was created. Additionally, as you look at the map, the star is indicated in orange with an arrow and the star name. The first white star on the procedure as you proceed inbound to Los Angeles are waypoints or satellite navigation points. They are identified by their name and the altitude block or altitude range that they'll be operating in. For example, the Angel star to the Angel waypoint at 19,000 to 24,000 feet. Continuing down the procedure, you would arrive at Circus at 12,000 to 14,000 feet and then connect into the approach procedure. The next procedure is the Rider 1 star. The Rider 1 star was renamed from the Crusher star due to a naming confliction. The Rider, Hall, and Ironman follow the same lateral path after based and will tie into the new RNAV RNP approach for Los Angeles. The Cormac waypoint was moved based on community input. It was moved further offshore, approximately 1/4 mile. The Cliffy waypoint is co-located with the Santa Monica Airport. Altitude of aircraft are up to 1,000 feet higher than the current procedure. The current altitude range for the Santa Monica procedure is 7,000 feet. The new procedure will have a window of 7,000 to 8,000 feet. Current ILS approach procedures allows for aircraft to descend immediately after passing Santa Monica. For aircraft flying on the RNAV RNP approach, the altitude restriction of Dodger provides a minimum altitude of 6,000 feet until approximately 5 miles east of Santa Monica. The ILS approach is still available for non-RNAV equipped aircraft. When requested, visual approaches will continue to be assigned when traffic allows. The next procedure is the OLA star. The OLA serves arrivals from the southeast. Again, you will notice the star in orange and the name identified along the route. The star connects to the Los Angeles RNP approaches for runway 24 and 25 left and right. The design of the procedure was shifted further over water to actually fly historical tracks and to take aircraft offshore longer. The next procedure is the Los Angeles International and Ontario star, the GOATS, and the Carl B star. First, the GOATS 1 serves Los Angeles arrivals from the southwest. This new star allows aircraft to be as much as 7,000 feet higher over Santa Catalina Island. The routing will be unavailable when military airspace control extension C1177 is active. The GOATS 1 is deconflicted from the Orange County Hero SID, and it ties into Los Angeles RNP approaches at Tornado. The Carl B1, currently there are no published arrival procedures to Ontario for aircraft operating from the west. The Carl B allows aircraft to be as much as 7,000 feet higher over Santa Catalina inbound. OP designs impacted the interactions with Los Angeles and Orange County departures, as well as San Diego and Palomar arrivals. Next, we'll look at the Los Angeles RNP Zulu to runway 24 left, the RNP Zulu to 24 right, the RNP Zulu to runway 25 left, and the RNP Zulu to 25 right. The stars connect to the Los Angeles RNP approaches. The RNP approaches will provide a more repeatable and predictable path, increasing efficiency and safety for Los Angeles arrival. The Clipper offset transition will act as an offload routing to be assigned by air traffic control only on a dynamic basis for aircraft arriving Los Angeles from the east. Weather conditions exist in Los Angeles that can limit the use of visual separation. The offset transition to Los Angeles runway 24 left and right approach can be assigned by air traffic control to maintain lateral separation between north and south complexes without the need to stagger arrivals to get below the mid-level ceiling of weather that limits visual approaches. Current ILS, localizer, and GPS approaches were amended to provide continuity with the new Metroplex design. The Los Angeles stars, Big Bear and Bruin. The Big Bear and Bruin stars were designed to replace the Bassett star. The Big Bear and Bruin stars follow the same lateral path as the Angel and Hollywood stars to the downwind transition at higher altitudes due to the longer flying distances from the west of Los Angeles. The Big Bear and Bruin stars are laterally separated and will provide independent flows for Los Angeles east flow operations. The Los Angeles and Santa Monica Zuma 1 star. The Zuma 1 serves Los Angeles arrivals from the north when landing to the east. The Walker Waypoint was relocated offshore with an altitude of at or above 6,000 feet. The Zuma provides OPD benefits when Los Angeles is landing to the east. It is deconflicted from the Long Beach Pacific, the Orange County OSE, the Burbank and Van Nuys Rocker stars. The Zuma star connects to the Los Angeles RNP approaches for runway 6 left and right and runway 7 left and right. It ties into the Santa Monica GPS Zulu approach, which maintains procedural separation from Los Angeles arrivals when LAX is landing east. It ties into the Santa Monica runway 2 RNAV GPS Zulu approach and is procedurally separated from Los Angeles arrivals when LAX is landing east. The Los Angeles Midnight Star was created based on community input. The Metroplex team considered community input and developed the Midnight Star to replace the Red Eye Star for midnight operations approximately midnight to 6:30 in the morning, local time. The current Red Eye Star requires aircraft to cross Santa Monica at 8,000 feet and routes aircraft towards Malibu. There are no vertical restrictions on the Red Eye Star west of Santa Monica. The new Midnight Star contains a vertical restriction of 8,000 to 10,000 feet over the new waypoint Cliffy, which is co-located at the Santa Monica VOR, and the second restriction of 7,000 feet over the new waypoint Sassy over the ocean. After crossing the shoreline, the lateral tracks remain over the ocean and away from Malibu. The Los Angeles Lady J RNAV Standard Instrument Departure is an RNAV off-the-ground SID. The vertical restrictions deconflict from the Los Angeles Ryder Ironman, and Hull stars. TCAS alerts between aircraft departing Los Angeles and arriving west and northwest are expected to decrease with the altitude restriction on the Lady J departure of 8,000 feet. The Los Angeles Orca 1 standard instrument departure is an RNAV off-the-ground SID that replaces the conventional Los Angeles Loop SID. Departures perform a climbing left turn back over the Los Angeles airport. Vertical restrictions at Clipper ensures aircraft comply with existing noise abatement procedures and deconflict from arrival traffic. Multiple en route transitions allow air traffic controllers to greater flexibility depending on the status of military airspace, restricted area 2502 Echo. The Los Angeles DOTS and Panda 1 SIDs replace the Holt SID. This allows for more unrestricted climbs while allowing for an optimized profile descent on the San Diego Comic Star. Lateral tracks were designed in conjunction with the Ontario Raji, Orange County Piggin, the Long Beach Fritter, and the Santa Monica PV SIDs. The Panda 1 SID replaces the Carver SID, designed to deconflict with Palomar and San Diego arrivals. The Los Angeles Dark 1 RNAV SID and the Los Angeles Triton 1 SID. The Dark 1 serves departure to the west and routed to the southwest, west, and northwest. It's deconflicted from the Los Angeles and Long Beach and Orange County's arrivals. It's designed to route aircraft away from military airspace or restricted airspace R2519 and warning area 289. Warning area 289. Provides more direct routing for ocean traffic and easier diversion of traffic flows from the San Francisco Bay Area and the Pacific Northwest. The Triton 1 serves departures to the east and routed to the southwest, west, and northwest. It's deconflicted from the Long Beach Pacific and the Orange County Osage Star. Designed to route aircraft away from military airspace, that restricted airspace 2519. Provides for easier diversion of traffic flows to the San Francisco Bay Area and Pacific Northwest. The Los Angeles Windy 1 RNAV SID serves departures to the east that are routed to the northwest. Deconflicted from Burbank and Van Nuys departure, and it provides for easier diversion of traffic flows to the San Francisco Bay Area and the Pacific Northwest. The Los Angeles Gardy 1 and the Los Angeles Tusty 1 RNAV SID. The Gardy 1 serves Los Angeles departures on eastbound runways, requires an aggressive climb gradient due to terrain. Aircraft unable to maintain a 420-foot per nautical mile climb will be assigned the Los Angeles Tusty SID. Current operations require air traffic controllers to aggressively vector aircraft away from terrain. Altitude restrictions were added to deconflict from the Ontario Sunshine SID, the Ontario Galarno Star, and the Los Angeles Big Bear and Bruin Stars. The Tusty 1 serves the Los Angeles departures on eastbound runways to the east and southeast. It's laterally separated from military airspace, restricted area 2503 and 2503 Charlie. Designed to provide an RNAV departure procedure for Los Angeles traffic departing on an eastbound runway who are unable to maintain the Gardy climb gradient of 420 feet per nautical mile. Santa Monica Municipal Airport is next. The Santa Monica Boget 1 Star, the current Chemo Star, is a conventional star procedure relying on ground-based navigation. This star now serves turboprop aircraft landing at Los Angeles and aircraft landing Santa Monica from the east. It's deconflicted from the Long Beach, Ontario, Palm Springs, and Orange County arrivals, and is also deconflicted from the Burbank, Los Angeles, Ontario, Santa Monica, and Van Nuys departures. The Santa Monica Banjo Star, the Metroplex duplicated the lateral track and vertical track of the Burbank Van Nuys rocker to develop a separate procedure for aircraft landing Santa Monica. The RNAV procedure has OPD benefits. It closely follows the historical tracks of the existing CME star. It segregates Santa Monica and Los Angeles arrivals. The Santa Monica Citrus 1 and the Santa Monica PV4 SID. The Citrus 1 Runway 21 procedure is an independent operation with the Santa Monica Runway 21 procedures inhibit independent operations with Los Angeles West Flow departures. The Santa Monica and LA airports are approximately 4 nautical miles apart. Extensive ground delays occur at Santa Monica due to Los Angeles departures demand. This will provide an earlier turn to the west after departing Santa Monica. This will reduce the time necessary to achieve course divergence, reducing delays at Santa Monica. The PV4, the study team suggested 1 SID for Santa Monica Runway 21. The design team determined the complexity of the current Santa Monica PV SID should be reduced. En route transitions were modified to mirror the Los Angeles DOT SID for eastbound departures, which will offer the opportunity for more unrestricted climbs. The en route transitions were modified to mirror the Los Angeles Panda SID for departures to Mexico, providing a smoother transition from terminal to en route airspace. The Choi 1 RNAV SID is designed as a Runway 3 RNAV departure. When Los Angeles on east flow, the Choi departure will have reduced interaction with Los Angeles departures. Vertical restrictions deconflict Santa Monica departures from Los Angeles arrivals. The Santa Monica 1 departure serves Santa Monica Runway 3 and Runway 21 RNAV equipped prop departures to the east and northeast. All Runway 21 prop departures will be able to utilize this procedure. Prop departures off Runway 3 must be able to meet a climb gradient of 500 feet per nautical mile. Provide separate prop departures routes to reduce interactions with faster jet departures. Additionally, allows for independent operations between Santa Monica prop departures off Runway 21 and Los Angeles departures to the west.
General project information. This briefing is for informational purposes and does not reopen the Southern California Metroplex environmental. Any noise issues should be directed to the appropriate airport noise office. Information about the Southern California Metroplex project is available on the Metroplex website, and this presentation will be available online. Additional public information. Before publishing the procedures, the agency is conducting public information meetings and webinars to further inform people about the changes. The FAA will notify the public through press releases and on Facebook, Twitter, Instagram, the Metroplex website, and possibly other additional platforms. The currently scheduled community engagement is highlighted in the following table. Note that this presentation is one of the 4 listed internet-based webinars, and that in the following weeks we will conduct a total of 10 community informational briefings. Please refer to the Southern California website for times, locations, and content for each of the community informational briefings. And now for the Southern California Metroplex website information. The first link indicates the Southern California Metroplex Environmental Assessment website. This is the main web page for the website, and all other web pages can be found by navigating to this page. For specific information, we noted the frequently asked questions and the various environmental assessment documents in the Google Earth files. Additionally, the final environmental assessment, Appendix F, contains the FAA responses to public comment. Due to the large size of this appendix, it was broken down into 3 files. Each of the 3 volumes is available on the website using the following URLs. And once again, this presentation will be made available on the website. This concludes our formal presentation, and we will now move to the questions and answer portion of tonight's webinar.
We've received a couple questions. The first one states, "This is good information, but where can I get more specific information on the procedures?" Our response is more information can be found on our FAA website. The FAA is also providing 10 public workshops starting next week throughout the different communities in Southern California. Our FAA subject matter experts will be available to explain the procedures in depth and answer your questions.
The next question states, "Is the FAA taking into consideration comments that I may have, and if so, how do I submit them?" A public comment period was provided during the draft environmental assessment phase of the project in the summer of 2015. The FAA evaluated and responded to more than 4,000 public comments received during the 120-day public comment period, and the final environmental assessment was issued August of 2016. These comments and all project documents can be found on the Southern California Metroplex project website at metroplexenvironmental.com.
The next question we have is, how can I find out more information about noise in my neighborhood? The EA website has detailed instructions on how to determine noise changes on Google Earth. Additionally, at our workshops, we'll have subject matter experts available to assist you to look at your neighborhood with your specific address and look at the change, either positive or negative, in DNL over your home. The next question is, I live in Culver City. How will these procedures affect me? The new procedures raise the altitude in the Santa Monica area from 7,000 feet to between 7,000 and 8,000 feet for traffic inbound from the west. Additionally, it creates a waypoint named Dodger that's at 6,000 feet, which raises the aircraft's altitude when flying the Star and the RNP over Culver City. When aircraft are inbound to Los Angeles and land over the water, they will be between 8,000 and 10,000 feet. Currently, they're at 8,000 feet.
Next question states, have these new routes already been implemented? Some procedures were implemented in November, but all of the procedures discussed this evening will be implemented on March 2nd or April 27th.
The next question we received is, will there be more webinars prior to the April 27th implementation? Currently, there are no plans for further meetings other than those listed in the webinar and our workshops.
Next question states, are you increasing capacity at LAX? The FAA does not determine capacity or flight schedules at any of the airports.
That's the final questions we received, Steve.
All right, we have no further questions. This will conclude our webinar presentation for the evening. We thank you all for joining in and for making the Southern California Metroplex project a success.